Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. In this video, I would like to explaining about heat treatment processes for the steels. So before the starting of the heat treatment process, there will be the general layout of the heat treatment process chart. So basically that will be related with the iron carbon diagram for the up to the 2% of the carbon is being present into the steels, because heat treatment processes that will be applicable onto the steels. So we are only considering up to a temperature range of the 1130 into the iron carbon diagrams, and the weight percentage of the carbon that will be up to the 2%, because steel is nothing but it will be the up to 2% of the carbon is being present with the iron. So you can say that it will be the hypoeutectoid steel, eutectoid steel and hypereutectoid steel. So if you want to learn in details for that hypoeutectoid steel, eutectoid steel, or you can say 0.8% carbon steel, or you can say hypereutectoid steel, so you will find a link in my description box. So just you can see it will be the similar to our iron carbon diagram. So above 723 it will be the formation of gamma austenite, or you can say that will be the 100% solid phase of the steels at just above the 723 degree centigrade. So as per the iron carbon diagram, so this 910 to these lines that will be known as a EC3 temperature line, or you can say upper critical temperature line. So after this austenite it will be converting into the alpha ferrite phase, and according to the solubility of ferrite with the carbon at higher temperature, so here that will be the point of 0.025% of carbon. So that will be having a 100% solubility to make a single solid phase. So that will be known as a alpha ferrite. And one more, that will be the ACM temperature line. So at this temperature line, this gamma austenite it will be start to converting into the cementite phase. So that will be around 1130 temperature line, or you can say ACM temperature line. And one more temperature line is there at around 723 degrees centigrade, that will be the AC1 temperature line, or you can say lower critical temperature line. So these all phases it will be before the 0.8% of the carbon. So that will be the formation of alpha ferrite plus pearlite at 0.8% of the carbon. We know that it will be the 100% pearlitic structure, and after that up to the 2% of carbon it will be the formation of pearlite plus cementite. So this point it will be 0.8% of the carbon and 723 degrees centigrade. So that will be known as a eutectoid point. So the transformation converting from this line, or you can say transformation, it will be passing through this line. So that will be the eutectoid steel formation. So now if you are increasing the properties of the normal steels, either it will be the hypoeutectoid steel, either it will be the eutectoid steel, or it will be the hypereutectoid steel, you will performing the different heat treatment processes. Then and then you will enhancing the mechanical properties of the steels. So in this video I would like to explaining about annealing process. So just you can see this is orange color, that will be representation of the annealing portions of the heat treatment process. So basically it is a softening process in which the iron based alloys are heated above the transformation range, held there and then cooled slowly around a 30 to 150 per hours, or you can say below the transformation range into the furnace itself. So that will be nothing but it will be the furnace cooling. So as shown into the figure, just you can see for the hypereutectoid steel, so the heating it will be carried out about a 20 to 30 degree above AC1 temperature line, or you can say lower critical temperature line. And for hypoeutectoid steel, heating 20 to 30 degree above AC3 temperature line, or you can say upper critical temperature line. Holding at that temperature, then it will be followed by the furnace cooling, or you can say annealing process. So what you get for the hypoeutectoid steel, it will be the formation of alpha ferrite plus pearlite structure. If you followed onto the 0.8% of carbon, or you can say eutectoid steel, so it will be the formation of 100% pearlitic structure. If you followed for the hypereutectoid steel, so it will be the formation of pearlite plus cementite structure. So basically for the annealing process, the holding time into the furnace, it will be around 1/2 to the 1 hour depending upon the requirements of the structures. So basic objective of this annealing process, that will be the soften the steels, relieve the internal stresses, reduce the structural inhomogeneity, refine the grain size, improve the machinability, or you can say increase the ductility and toughness. Now we will discussing for the sub part of the annealing process, and that will be the stress relief annealing. So what happens, just you can see in this annealing process, that will be performing just below of the temperature of AC1, or you can say lower critical temperature for hypereutectoid steel, and just below the temperature of AC3, or you can say upper critical temperature for hypoeutectoid steel. With the subsequent slow cooling, the aim of which of the reducing the internal stresses which will be developing during the manufacturing process. So without changing its structure, it will be changes the grain refinement. So by this process, that will be having a good mechanical properties, it will be having a good refinement into the structures, or in simple way, by this stress relief annealing process, that will be not cases the any phase change, but that will be performing the recrystallizations into the structure, so which will be enhancing the mechanical property in second sub part of the annealing process, and that will be the process annealing process. So just I can see for the process annealing process, so that will be the regions. So in the process annealing used to reducing the effect of the cold working process, which will be generating into the metal forming processes. So basically ductility is being increasing with somewhat the decreasing into the internal stresses. In this process annealing, metal is heated. So just you can see at the temperature range of just below that particularly lower critical temperature range, or you can say around 550 to 650 degree centigrade. Holding at that temperature range, and then after it will be having a slowly cool, or you can say furnace cool. So that will be similar we discussing for the annealing process. So in simple way, if annealing is there, so there will be the always cooling, it will be into itself as a furnace. So by this it will be completely recrystallizations into the steels. So this heat treatment is used into the sheets and wire drawing industries to remove the effect of the cold working process into the metal forming processes. So if you like this, then subscribe and share more the mechanical engineering tutorials. Thank you so much and keep watching.